Yeah, wow. So different methods for fluids. I mean, there's quite a few. The three that come to mind, right, are finite volume, right, and finite element. But I'm going to focus on finite volume, smooth particle hydrodynamics or SPH, and then a discrete particle or discrete element modeling. So I mean, FVM, finite volume. That's the bear of it all. That does most of the heavy lifting, I think, in the CFD industry, right? A traditional method, probably the first of those three, and can solve Navier-Stokes for an insanely wide range of problems. But it's a heavy lift, right? So if I'm analyzing, for example, a free surface, right? So waves, right? So the interface between, say, a liquid and a gas, and I want to capture some of the diffusion happening at that interface, right? So I've got splashes of water into the air, I've got bubbles of air into the water. Then the finite volume method starts to slow down because you need a really, really tight grid to analyze that and to capture those details. Of course, you have to ask yourself, are those the details that, do we need to capture them? If the answer is yes, you might want to consider looking at an SPH method or smooth particle hydrodynamics. So when we have a multi-phase problem, and you can think of, for example, a washing machine, right? A seemingly simple device that we have in our kitchen, but in reality, there's a lot of physics on the fluid side happening, splashing and a wall film dripping. So we've got a lot of, say, F equal MA happening, and a tool like smooth particle hydrodynamics, which sort of analyzes the fluid as particles sort of combining together and then sort of separating, could be a more efficient tool. So certainly for multi-phase problems and for what we call volume of fluid or free surface type problems, an SPH method might help. Now, on the other side of things, we might have a mixture of liquid and solid. And an example there might be a packed bed, which is a common sort of design that we use in bioreacting and chemistry and processing industries, right? So for that, we've got quite a complex interaction between the liquid, perhaps there's gas bubbles, penetrating, and we might also have, of course, some of the solid sort of particles in there. So we've got several different phases, and the overriding physics might be the collisions or contact between some of the solids inside the liquid. It acts like a liquid, but it is a solid. For that, we have a discrete element method, DEM or DPM, if you will, discrete phase. And that type of approach is a little bit better at capturing some of those sort of kinetics, if you will, between all of the small sort of particles bouncing off each other. So I think that of the three different methods, finite volume, smooth particle hydrodynamics, and discrete element, you can solve any problem, any phase, multiple phases. But I would certainly start with a finite volume, single phase, and then ask yourself, do we need to start to account for, say, liquid and gases or liquids and solids? And then you can go from there. But those tools, particularly the SPH and DEM tools, are really fast. And a lot of them, because they're newer, are actually built on GPU natively. So we're seeing some pretty amazing simulation speeds that we're not really used to in the finite volume world.